Good afternoon, everyone. I was talking to myself, but I didn't have my mic on. I'm glad to see you all. I'm going to wait for a few more people. And how I'm going to begin, I mentioned I would start with 1 hour of problems that I know students may be having trouble with. I also want to talk about the test, so I'll just do the review first and then talk about the test. It's not a review of everything. I just want to look at interest rate conversions and someone just texted me. Interest rate conversions and dividend problems or problems of stock valuation. There remains to be some confusion. I think some students might be confused if we're having class. Let me just send them a quick message. Of course we're having class. I just didn't send any notes yet. I want to see if I need additional notes. I'll send a quick message. Okay, I'm just sending it message with a subject header, streaming now. Yeah, because I didn't send notes, so people might think that we're not having class. All right, so this is where I want to pick up. I'm not sure what happened in the lab yesterday, but you can let me know. I know that you had a lab, so the TA was supposed to review the exercises I gave you and answer questions. Hello. And I still did receive some questions about interest rate conversions. So we did have this discussion about conversions, and there were two broader concepts that you need to learn. One had to do with computing effective rates from stated rates. And I use this terrible word nominal, and I don't want you to confuse it with the other kind of nominal. But sometimes people say, I should actually just change that to stated rate. So stated rates. It's not in the playlist. Someone's telling me it's not in the playlist. I put it in the playlist. I'm going to check. I'm just checking. I'm here. I put in the wrong playlist. Oh, it didn't store in the playlist. Okay. It should be now. Oh, I think I didn't hit save. I hit done. Anyway, now it's there. So anybody who's coming late, anyone who's coming in late, I just started really, so you didn't miss anything. Okay, so I'm going to review interest rate conversions. So this is the concept of getting effective rates from stated rates. So stated rates are the rates that you usually see in contracts with your credit card company, with your bank, with a lender. They will state the APR, the annual periodic rate, but that's not the same as the effective rate. What's wrong with it? What is What's up with that? The issue is that so in the document 2.2, I expressed a variety of rates, and more popular ones you're going to see. So for stated rates, you know it's a stated rate when you're told that it's a rate over the year, but it compounds over a different frequency. That's how you know it's stated. So for instance, an annual rate compounded daily. Those are different. I did say this before, so please watch the videos, because I don't really want to repeat myself. But I am right now. So it's stated over the year, but it compounds daily. So this just reflects the simple interest, not taking account of every day there's interest, and that interest also gets charged interest. Okay, so it's just ignoring that, and it's giving you the fraction each day times 365. It's giving you the rate each day times 365. That's what that is. And mortgage rates, similarly, they're stated over the year. So they're always stated over the year, these rates, but compounded over a different period of time, only by months. So this is equal to the effective monthly rate, but times 12. So they think, oh, well, this is what you pay over the month, so times it by 12, that tells you what it pays over the year. But that's ignoring the compounding effect of interest. Okay, so that's why we have to do the opposite to get the effective rate. The opposite to find the thing I circled in blue would be to divide the rate you were given by 12. For the daily rate that's above, the daily rate stated is just the effective daily rate times 365. So they've just ignored that each day there's interest, and then that interest also has interest charged on it. It ignores all of that and just says, well, take the rate per dollar, this is what you're going to pay in a day, and just times it by 365. It's an approximation, it's not precise. Okay, you shouldn't use it, you shouldn't use this rate in your formula. You should only use effective rates. Okay, so then similarly, the quarterly rate. Quarterly, it's an annual rate compounded quarterly. If it's that, then that's an R. It's a stated rate. The stated rate is the effective annual rate spread out over the year. So you have to multiply that by 4 to get the stated rate. It ignores the compounding effect. Every quarter there's that interest, and that interest also gets charged interest. This R ignores that, so it's not a good measure of what you really pay. So the annual rate compounded, semi-annual, those are different. Since they're different, this is also a stated rate. So when the statement over which the rate is occurring is different from the compounding frequency, when those are different, it's a stated rate. Now contrast that with this. These are effective rates. It has to be a rate by day compounded daily. The monthly effective rate has to be the rate per month compounded monthly. The effective quarterly rate has to be the rate quarterly compounded quarterly. Okay, so those are the same now. And that's what you need. Those are what you need for your formula. Okay? So, taking you back to 2.3 handout. I haven't saved them. I have to open them each time. Okay, so this is where I started. So all that I've said is summarized in the relationship. So if you want to find the effective rate from a stated rate, you have to do the opposite. You have to divide the stated rate by the number of compounding periods per year. So you got to chop it up into those portions. All right, so if it's a quarter, then you have to divide the stated rate by 4. If it's a month, you have to divide by 12, the number of compounding periods in a year. The R is always stated over the year. Annual periodic rate. Now, what I did, so that's the first concept. So let me just leave it like that, because then I want to talk about the second piece. If you want to get a different effective rate than the one that you have, you convert it to another effective rate. So that's another kind of conversion you can do, or you might need to do. And I showed you several examples, or I showed you some examples. And well, in the notes you have several, but on this sheet there's one. What I've done below is I've said, okay, first of all, okay, so just using the first formula. In the first formula, you were given an APR, I showed you an APR on my credit card of 18.4, and credit cards give stated rates compounded daily. So those are different. Since these are different, what I have to do immediately is divide by how many days in a year? 365. So that's why I do that. And I get from there the effective rate. So now I have the effective daily rate. And I'm done with that problem. The second problem is now I want to know if that's the effective daily rate, what is the equivalent rate over the year. So if for each dollar balance outstanding on my credit card, how much would I pay if I left it as an outstanding balance over the year? Well, you would pay for each dollar. How do I figure that out? Well, I make this equivalency. I show the factor 1 plus EPR, the daily rate, plus 1 plus the annual rate. And I think, what is the relationship between them? And if I have to, I'll go back here and see they're related. I take these two and I can get one from the other, because 365 factors of, well, 365 days makes 1 year. Okay, so I solve that and I get the actual rate, and then I compare that to, so that's actually what you pay for every dollar if you have a dollar outstanding for the entire year. This is what you're going to pay for that dollar. 20%. All right, so yeah, don't leave balances outstanding, because if it was $100, then you'd pay $20. If it's $1,000, you pay, right? If it's $1,000, you pay $200, and so on. So what's next? Okay, so then I can ask different sorts of problems, but basically it's a variation on these two. Either you need an effective rate from a stated rate, and that's a relationship, or you need an effective rate from another effective rate, and these are the equivalencies. I also threw in, and you have a sheet, like a page just like this, but there's one thing that's different. I added an extra term here. So where does that extra term come from? Notice as I go from right to left, the effective rate is over a smaller, increasingly smaller interval or frequency. people are asking me about the test. I'll talk about the test after this hour. Okay? After the first hour. So we go from a half of the year to a quarter of the year to a 12th of the year to a day. What is the smallest interval of time that you can compound over that my notes discuss and the textbook discusses? Does anybody know what I'm talking about? So we're going to get smaller and smaller and smaller intervals. So in this picture, I've cut a year into half, right? And here you would pay, so I did discuss this last time. So it's the effective period rate each period, or each half. So in there, it's a half year rate, and here's the effective semi-annual rate. For a quarter, it would be, same interval, but I have smaller. Oh, wait, make them a little bigger. Right, there's 4 intervals, and each of those are effective quarterly rates. Now, 4 of those compounded as factors to the power of 4 will give you 1 full year. And I explain the motivation for that. I explain that you would want equivalency because let's say someone was gave you an annual rate, but you wanted to know what is it effectively that you're paying each period. Okay, so that would help you figure that out. So if we move over to this side, I could make a drawing with 12 tick marks. Here I'd have 365. And then over here, I would have continuous, instantaneous tick marks. The smallest interval possible would be continuous. How would I represent that? That would be represented. Give me a second. Okay, so in the document 2.13, I explained that there's another kind of compounding. Imagine compounding instantaneously. Not daily, not monthly, not quarterly, but every instant. So it would look like this. Actually, let me write this. I'm going to combine the 2 formulas, the one up here and the ones down here, okay? So remembering that, where does this come from? This comes from, I'll just use these 2 for now. So from the first formula, if I was given a stated rate, the R1 over 365, I would have to divide by 365, right? And then add 1 to the power of 365 to get the effective annual rate. So similarly, I'm going to, so some people are saying every second. More instantaneous than a second. It's like instantaneous. But yes, seconds are still too big. Like it's happening every instant. That's the concept of continuous compounding. And in practical terms, you don't see that, but it's useful for theoretical finance, okay? And a lot of the results that we get, in finance, derived using this continuous compounding concept. All right, so this, I can write this as, let's see. Oh, I need my black there. So what is this? So this might be a little bit confusing, but it shouldn't be, okay? Just remember that the fractions are all ends. So 1 over 365, or 1/12, or 1/4, or 1/2. Okay, they're all the ends. And then I have to divide by like the flip of it, because they have to cancel to make 1. Like these cancel, multiply to make 1, right? And these multiply to make 1. Right? So that you're using the fraction of a year. And then that's how many periods of months in a year, 12. So because of that, I'm continuing the pattern. If you have a good pattern recognition, this should be easy for you. So then you flip this, so this would be 1 over n. And then since that's recognized as 1 over n, also and this is recognized as what we're dividing by, then it's also this, right? How many of these we do. So that's also 1 over n. And you guys never have to repeat this. I'm just trying to prove where this comes from, okay? Just follow me superficially. As I'm holding your hand, showing you this. So this has the same pattern. This is the stated rate. Then I divide by 365 to get the effective rate, and then to the power of 365. That's that. And what I want to do is I want the interval to be as small as possible. In other words, I want it to be as small as possible, so this fraction is going to be small, and I also want infinite periods of compounding. Just like here, I want, here this is the fraction. Oops. Sorry. I don't know what happened. Here's the fraction 1 over 365, and then I divide by how many days that represents here are in a year. So I want this to be huge, right? So that's what we're doing as we go from left to right. I'm making the number of periods of compounding bigger and bigger and bigger. Well, what's the biggest it can be? Infinity. And that's what I'm going to do. I'm going to write limit as n goes to 0, because that's what will make this become infinity. So at the same time as many periods, I want many periods of compounding, I want at the same time my interval to be small. I want it to be so small, I want it to go to 0. Okay, at the same time I'm making that interval so small, I'm making the number of intervals huge. So this is exploding. Also, this is exploding. So it turns out that this actually is the same as, or we represent that as the exponent R0. So this is something you would have learned. I'm going to put 3 bars here because these are like the same thing, okay? So you might have learned this limits, or maybe in calculus, or anyway, pre-calculus, you would have seen that the exponent function is equal to this limiting function, right? So I'm not going to show you this limit again, but I'm going to replace it with this. But this is not just coming out of anywhere. It's imagining that the interval is becoming the smallest it can become which makes an infinite number of intervals fit into a year. Okay? That's what this is saying. And it replace it with that. All right, so you have this string of equalities that you can use. Notice that this ties all the way back to 1 plus EAR. So you go through this and you see that's also 1 plus EAR. Okay? So because they are effective, the compounding effect is captured, and these are the equivalent ways of writing it as effective rates. So yes, Rn is just a notation. You don't put these numbers in it. These are just notations. Okay, these are just notations. R sub n is just notation. So I really recommend that you read through all my notes, go through all the problems, and then check the solutions. Okay, try not to just read or glance at the materials. And you really, if you don't have a printer, maybe you can borrow a friend's printer and print these notes out and have them in front of you, because I don't see how you can be reading this from a screen. I don't think that that is ideal. It's ideal to print it out and have it in front of you and work with them. These were not invented to be, these pages that I've created were not intended to be read off of a screen. It's very complex. There's lots going on here. I think you need to print them and have them in front of you, or on a tablet. But I think it's easier to go to a friend and print if you don't have a tablet. Okay, so print everything out, have it in front of you. These are your study notes. I'm prepared them all for you, so use them. Don't go searching. You don't need to search anywhere on the internet. Some people waste time doing that. You don't have a lot of time. Learn what I gave you and ask me if you don't know. All right, so let's do some problems with this. And if you didn't follow that, you guys can watch the video again. So where do I want to go? Why don't I look at the test? I gave you prep questions, right? Let's look at the prep questions. Ah, maybe I didn't give you prep questions. Did I? Let's see. Oh. Okay, let me send you these. And we can work on some of these together. You can continue studying. Okay, someone asked for 2.9. Let's see. Let's do that one first, and then I'll send you these test prep questions. Did I send them to you? Did you guys get the prep questions? 2.17. I have to double check. Okay, 2.9. I sent you up to 216, right? You have 217? Okay, you have prep questions. Good. Okay, so I gave you all of them. Good. Okay, let's look at 2.9. Thank you, Senna. Mm-hmm. Okay. Okay, question 5. 5? You want question 5? Okay. Right. So I've given you everything. I haven't heard complaints. Just that you want some help with this question 5. So maybe something's wrong with question 5? This question 5? Okay. All right. So in the handouts I gave you, I explained that bonds, even though I introduced bonds as having, I showed you how to solve bond problems. And then I explained that in reality, coupon bonds have stated rates that make payments every 6 months or every half a year. Right. So for this problem, you have a corporate bond with a face value of 1,000 and coupons paid semi-annually. It sells for this amount. So you have the price. The term to maturity is 14.5 years. So let me ask you, did you look at this handout I gave you on how to solve problems? So what you should be doing is following these steps. I know it's a lot of material, but I'm telling you already we're going to fall behind if you guys don't keep up. I don't want to fall behind. So I gave you everything, and 214 tells you how to solve problems. Okay, so the steps you take. So 214, and I have mentioned this before. Step 1. So this is 2.214. First step is, in reading a problem, identify timing of payments and if there are payments. And then convert all rates, interest, discount, growth rates, to effective rates that compound with the same frequency as the payment frequency. So if payments are daily, then you need the effective daily rate. If payments are semi-annual, you need the effective semi-annual rate. So on, okay? Step 2, draw the timeline and determine whether the problem involves a simple time value of money problem, an annuity, with or without growth, and or a perpetuity, with or without growth. Then focus on the portion of the problem that uses the formula exactly as is. So make your timeline and find a snapshot of the timeline that matches the formula you have. And then if it's not exactly the way that the formula's timelines are set up, then modify the formulas to the desired positions on the timeline. Those are the steps. I'll work through those. And then here's the hints about interest rate conversions again. Okay, so I show the broader things, converting effective to effective, and then using this to convert effective from stated. So for the problem that we just saw, so keep that close by with your formula sheet printed out by hand, and you should be able to solve this unless I made a mistake. Let's look at the solutions. I'm going to grab the solutions. Okay. So what we need to do for this problem, since we know bonds, so now you should know bonds they have yields to maturity that are stated. But what happened is I wrote this for you. I made it easier. Effective rate of 5% compounded semi-annually. So I told you it's an effective rate. So I gave it to you off the bat. You didn't have to divide anything. Is that confusing you? Well, it's because of the way I said it. I said effective rate. This is what I said. I didn't say stated rate. I said effective rate. Okay? So what did I say in the original? Let me make sure it says the same thing here. It might have changed something. I said effective rate in the question. So you got to read carefully. So if I don't say anything, the assumption is that it's stated. Okay? If I don't say effective, then you assume it's stated. Is that all right? Is that acceptable? I use the word effective. If I said is 5% and I didn't say anything else, then you would have assumed it was an R1/2. But directly, the way I've written it, it's EPR 1/2. The coupon rate, okay, so that's what you're trying to find, is the coupon rate. Okay, good. Okay, good. Any other questions? Any other direct questions, or I'll just do a couple of problems in the prep. see the prep. Yeah, let's look at 217. I'm just going to check my phone because some students asked for a specific. I'm just looking at some text, sorry. Write me questions. See if I can do a couple. Oh, you wanted question 6. Okay, let's just see here. How did you guys do? Okay, which problems on this prep 217 would you like me to do? I was gonna do a stock problem. Calling it 1D. So Leonora asked me, are the APR the stated? Yes. And EAR, EPR effective? Yes. Okay, so Ben's asked for 8. So let me highlight this one. And then 8. Yeah, that's kind of the questions I want to do. Okay, let's do 8 first, and then I'll go back. Okay, ADF. Okay, some people are asking me about Chapter 7. Chapter 7 is on the first test because it's in the first week. I just didn't put it in the lab problems because you had a lot of lab problems to do, and I really want you to have enough time to work on these, reviewing these papers or these documents. So it's still, though, Chapter 7 is on Test 1. Whatever is in the Week 1 materials is on the test, okay? It's just that I didn't put it in the My Lab Finance problems. Okay, company ADF has been paying a dividend of $1.25 per quarter for several years. Okay, this is really important. So you're learning by doing. You're learning by solving problems. All right, so the idea is this company's been paying this dividend every quarter for several years. Now, as a prospective buyer or investor in this company, you're gathering information. Its management plans to continue with this dividend for 2 more quarters and then to start increasing its dividend by 1% per quarter, with the first increase in the 3rd quarter of this year. So your timeline is really important here. The planned increase in dividends will be announced today If ADF stock currently requires a return of 18% effective per year, how much should its stock price increase? Because there's lots of information in here. Where do we start? The first question you need to answer is, when are the payments? That's the first thing. So the payments are, there are payments, yes, if you were to buy this stock. And the payments are quarterly. So because they're quarterly, you need quarterly rates. Which rates do we have? We have this one, and they tell you it's 1% per quarter. And there's no other information. Assume that that is effective. It doesn't say it's not. So that's effective. And then you're given that it's 18. Okay, so then this, and it's effective per quarter. So that's good. So those are that's the growth rate. The growth rate needs to be also quarterly for the formula. The required rate of return, that's going to act as your interest rate for your formula, because this is a stock problem, is given as 18% effective per year. So you need to convert this one to quarters. We know how to do that. Okay, so we're going to start there. So you're going to start there. And you're going to say what you need and what you have. And until you get the hang of it, just use this approach. So you need the effective quarterly rate. So that's EPR 1 quarter. And we're going to solve them as factors and factors of accumulation. And what we have is an EAR, effective annual rate. Now, what is the relationship between these two? Which one is smaller? This one is the smaller one. And 4 of these small ones makes 1 year. Right? We know that because four quarters makes 1 year. Okay, 4 times 1 quarter is 1. All right, so this is 18%. So this would be 1.18. And what you want to solve for is this thing here. So I'll just write it out. So you want to find the equivalent rate over the quarter. So you have to take 1.18. You have to, the opposite action of putting it to the 4th power is inverting that, -1. And now you have the effective quarterly rate. So that's the first step. So you have to solve that. You know how to punch that in your calculator? .18 to the power 4, flip it, or to power 0.25 equals -1. You got it? Okay, so good. So that's going to be 0.04224 ... Okay, so then I'm going to put this so you just got to remember how you put it in your calculator. I'm going to put it in just like this, okay? Well, let me see what I did for the solution so I can do the same thing. Got to confirm. I don't want to contradict myself. So what I did here, did I tell you how to store it? No. Fine. I didn't tell you anything about storing it. So, okay, I'll just say store 1. So you put this in store 1. Now remember, you put the decimals in. If you need to have the percentage for the calculator, you can multiply by 100 first before entering it into your TVM keys. Okay. Now, we have a timeline. So I haven't drawn the timeline, but I'll draw it for you now. So this is like step 1. That was the rate I needed to change. So let's read through this. Its management plan to continue with the dividend for 2 more quarters and then start increasing. Okay, so it's going to look like a timeline. And these are in quarters, okay? I can make my timeline in quarters and also mark years just to keep track of what I'm doing. Okay, so these are quarters. So a quarter from now, I'm going to write Q1, Q2, Q3, Q4, or maybe not so many. Wait, let's just do that. Okay, so it's $1.25 for 2 more quarters. Now notice I did not put the $1.25 here. Why did I not put it here? Does anybody know? Nobody knows? Why don't I have one here? There's no dividend because if the dividend was today, right now, and I wasn't holding the stock, I have to wait a number of days before I can actually claim a dividend. You can't just get a dividend and like buy stock and get the dividend that day. You can't do that. Okay, there's a waiting period. Right, you would have to wait. Okay, and there's details about that in the textbook, so have a look at that. These are the kind of the details. Well, you should know that, okay? But this I repeat this now in case you didn't realize that. So you won't get that dividend. You have to wait. Okay, so even if it was coming, 30 days from now, today and 30 days, you still wouldn't get the first one. You'd get the one that comes after a waiting period. Okay, so no dividend there for you. So that's for prospective investors. You'd have to have it. You'd have to be an owner already, a shareholder already to have that one. Okay, so then what do we see here? So this is just the nuance of this thing. Now looking at this, what is the pattern that I recognize? So I see I can apply my formula. So I would apply my formula if this was to go on forever. So if, let's say there was no knowledge of this increase and it was just 125 forever, each share would be worth, and so I mentioned it there, like before announcement, right? Before the announcement. I just have the information about the 125. I have no reason to believe it's going to change. So it's a perpetuity of 125 with the effective quarterly rate. That's it. And I'm writing it big like that. You can put the number in there, but to get it out of your calculator, just use recall 1. If you put it in as a decimal, it'll work. So 125 divided by recall 1 will give you the answer there. Everyone gets that? No problem? Yeah, not till the first quarter. Okay, so that's if before the announcement. But after the announcement, what happens? After the announcement, you have what you have here is you have a growing annuity, but it's off time. It's missing, it's like one period off. Do you see that? If you look at your formula sheet with the timelines, okay, I'll just draw it here. Annuity with growth should look like this. Not annuity, but perpetuity with growth. Why did I say annuity? Perpetuity or annuity with growth anyway, either of them. Okay, perpetuity or annuity with growth has this pattern. You have to wait one period and then the growth kicks in. But we don't have that. We have this other thing here. So what do? We make adjustment. You can't see my timeline. Let's see, there you go. Okay, so this is the pattern. You have the first payment, and then the first payment with one period of growth, and then the next with 2 periods of growth, and so on. But we don't have that pattern. Or we do have that pattern, but it would be starting here. Like ignoring this amount here, but looking forward. So what I see is a growing perpetuity, because this is going to happen forever, they tell me. So this will go on forever. But it's shifted one period. So what I need to do is realize that. I'm going to make this bigger for a second. What I'm going to do is figure out all of this that's happening up until here. So this all and out to infinity is a perpetuity with growth. Okay, that's my short form, perpetuity with growth. But it starts here, one period before the first payment. And that leaves out this bit. We still haven't talked about this. So I have to add this to this perpetuity with growth. But it has to happen at time 0. Okay, so that's why I discount this piece. And then I discount this perpetuity with growth. That's what the formula, that's what the answer is saying. So this piece discounted one period, quarters, and then this amount discounted also one period. Do you see that now? That's what's happening. So let me flash the answers in front of you. I keep accidentally turning this off. You know what? So let me show you that from the solutions that you're staring at. You probably have those. I don't know, it's slow. I guess it's a really big document. Okay, so this is what's happening here. These are the solutions I sent you. So this is that $1.25 that I discount. That's all that's happening here. This is the discount rate. This is 1 plus the interest rate that we calculated per quarter. So that's discounted to time 0. And then there's this part, which is the perpetuity, and then have to discount the whole perpetuity back 1 period as well. And that's how I solved it. Does it make sense now? So because this is not programmed in your calculator, you just have to be careful. You have to use the recall value, right? Because you have to maintain all the decimal places. And I will be grading decimal places. Or the graders will give you marks for the decimal places. If you don't have the exact decimal places, you will lose a half a mark. So the test will be, I'll talk about the test now because it's 7 o'clock. The test will be consist of 10 questions, and you only have to complete 8 of them. Okay? And you have 6 hours to do it if you want, but if you are gauging your understanding, you should be able to complete it within an hour and a half. You should be that proficient to complete it in an hour and a half. So with an hour and a half, that's 90 minutes, right? Divided by 8, that's about 11 minutes a question. That's how long it should take you. If it takes you longer and you're still learning, it's okay, because I'm not going to know. But just to give you an idea, they're not going to be dramatically different from the ones that I've given you here. So let's make sure you understand these ones so we can continue, or so that you can do well. And you can continue in the course with the knowledge of this the first week material. So I've given you 2 weeks so that we have a little bit of a lag, and I introduced new material not yesterday, but the other day, Tuesday evening, and I want to continue with that material, and let's see how far we get, and then I'm gonna pop on some more, and that will be tested the next Saturday. Okay, I know I keep it going, but this is a condensed format, and it is all doable. You just have to keep up and keep me informed of your needs, as well as the TA. So I'll do one more problem, and then I'll get back to what I was teaching you Tuesday's class. Yes, Harper, you have the whole 6 hours to finish the test. I'm not gonna know. Okay, and you just can't cheat, or I'll know if you cheat. Because I can tell from the papers. So make sure you do your own independent work. If you cheat, you might be copying a wrong answer, and I'm going to know. So do your own work, answer the questions, showing me your work, and I will give you part marks. Not like the multiple choice questions. I think there's one question in there that's multiple choice, but you can show your work in solving it and picking the answer, and I'll give you part marks. Yes. Okay, so I'm getting a lot of questions about the test. Let's see. So the time limit, I'm going to email it to you at 9 a.m. on Saturday, and you'll have till 3 p.m. to send it to me. Okay? If I will be asking you how many decimal places, but if I don't ask how many decimal places, stick with 4 as a percent and 6 as decimal for decimal places, for rates, for interest rates, growth rates, things like that. And for dollar answers, it's always 2, just for the cents as a final answer, but never round intermediate calculations. If we do all 10 and one is wrong, we still get complete marks. Do all 10. I'm not sure what the question is. If we do all 10. Oh, no, you cannot answer all 10 questions. I'm going to give you 10 questions. You have to pick 8. My philosophy is that you need to know what you know and know what you don't know. Okay? So steer away from the problems you don't feel that confident with and do the ones you're confident with. Anyway, it just gives you a little bit more control, and because it's such a condensed course, I'm a little bit more forgiving. But again, the final exam is out of my hands. I'm going to do my best to prepare you for the final. So I'm hoping by the end you're going to know all this material, keep studying this. Even after the test on Saturday, keep studying this material. Find out with the TA will mark up your test, so you'll see where you went wrong, and keep working with it, okay? Because you'll need it for the final exam. So my format is going to be different than the final. The final is going to be more like my finance lab, where you have questions and then you plop in an answer, and you don't get multiple tries. You have a time limit. It'll be 3 hours, and that's it for the final. You should email your answers to me directly. Yeah, I don't see the purpose of putting them in Learn, but maybe I'm missing something, because I think it'll just go to my email anyways. So yeah, just send them to my email. And the test questions will be similar to the prep and the other questions, all the problems I'm giving you, those kinds of questions. So the 3 tests are not cumulative, but the final is. That's right. That's right. The 3 tests are just week by week. But you understand the stuff that you learn in week 1, you're going to be using in week 2, just to let you know. If you can't print out the test paper, so the test paper is just going to have the 10 problems on 1 page. And then you can read them off your screen. I think it's going to be hard to read, but it's easy to make errors, or I don't know. Maybe, I guess you'll read it off your phone. It'll be closer to you. Probably that would be better, to read the problem off your phone and transcribe how to answer it. I don't know. I find it hard to look up at a screen and down. So maybe with your phone or a tablet, it'd be easier. And then on separate pages, answer. So if you want to use a tablet to answer, you want just blank pages on a tablet, and you write your answer and then send me those, that's fine with me too. Just remember to keep saving. Don't lose your work as you go. Lots of questions here. No, I'm going to email you the test, okay? So the test will be emailed to you. That's different than the final. The final will be through Learn. I have to confirm that. I'm still not sure how we're administering the final. I need clarification on that, but I'll let you know. I'll make it clear by the time I know. So somebody asked, did you just take pictures rather than scanning? Yeah, take pictures with the phone, but please make it clear. But the thing is, I want you to use your computer and string them together, like put them together in a single file. When you send multiple sheets, it just gets really messy. I could lose sheets. You could lose sheets. So put them all in one document so they're all together. So if you do take photos, that's fine, but combine them. All right, is that all the questions? So let's just do some interest rate conversion problem. So yeah, I'm giving you part marks. Often they are not given. You just have to have the final answer. So it's a consolation prize, to get part marks, but in the end, on the final, you're not going to get part marks. So get efficient by the time it comes to the final. The final is going to be on August 17th. I got the date and the time. Let me see. Let me confirm the time. So 9 a.m. to 12 noon. Okay, that's going to be August 17th is the final exam. I'll put it in the chat. Okay. And that will be on the computer with Respond Us, and you're going to be filling in or selecting the best answers. Okay, so you have some time to get proficient. Almost a month. All right. I want to go out here. Okay, so I was asked to do D. So it's a good question. D is a little bit different than the other ones, right? So here you're asked to use the effective annual rate of 15% to find these different rates. Let's just go through them for practice, and then I'll answer the last one. So the first one they're asking you for is the semi-annual rate compounded semi-annually. Which rate is that? In the symbols that I taught you, which rate is that? It's stated over the same period that compounding frequency occurs. So that is what kind of a rate? Nobody knows? Yes, perfect. EPR 1/2. That's what it is. So this is an EPR. It's an effective rate because these match. This matches with that. Very good. Excellent. All right, the next one. Annual rate compounded quarterly. Which one is that? So they don't match. R's are always stated over the year, and this is the frequency. Okay, so it's an APR, it's an annual periodic rate, so it's an R with a quarter. Right. Right. Right, Michael. Very good. So he's saying that this is found by doing 4 times APR 1/4, which is correct. So it's just, it's a simple interest. Go back in the notes and see what simple interest is to remember why we're multiplying. I'll go through the videos. All right. What about this one? Which one is this one? So this, because again, these are different. This is stated over the year, but compounding is continuous. We write R0. Okay, that's the one we just talked about before. Continuous compounding. Now notice, there's no effective, there will never be an effective compounded, an effective continuously compounded rate. That doesn't make sense. It's not tractable, okay? It's not tractable to have a continuously compounding rate that's effective. We write it as a stated rate, and we turn it into an annual rate, and we use it, we can convert it into other effective rates, but we never talk about like APR 0, like we don't talk about that. Okay, just think about that as it's impractical. Okay, doesn't make sense. Anyway, think about that. You'll never see that. Okay, so then the last one, which I was asked to do, was the annual rate compounded every decade. So that one, because these are different, it's still a stated rate. It's a periodic rate. The subscript that I use is going to be different than the ones I've done before, because look, I haven't told you about fractions, or I've only used fractions of a year. It's always been a fraction of a year, but you should be able to understand, and I didn't do too many like this, but you should be able to understand how to handle this when you do more than a year. So because our fractions are always, or our subscripts are always in portions of a year, we're talking about 10 years. So that would be the subscript. And because R's are always over a year, but I want, yeah, that's it. Yeah, that's all it is, isn't it? Yeah, that's all it is. Okay. So all of these, I mean, you could solve them different ways than I did and still found the same answer. That's just fine. You might have a different approach. Okay. But what you get to begin with is EPR. This one is given to you as the EAR, or EPR1. So that's the annual effective rate. And then what you're going to do to solve these, most of these are stated. So you need to find the equivalent effective, you have to find the effective rate, the effective periodic rate. I wrote, yeah, that looks funny. That should be a P. EPR. Anyway, you should be able to find the effective periodic rate in the equivalent interval of time. and then turn it into a stated rate. So that's for all of these. To do this one in particular, so I work backwards. I say, how will I find this? Just like I did here, right? Michael told me this would be 4 times EPR 1/4. So I need to find this first and then multiply by 4 to get this. For this one, we know how to find that because there's a relationship. The fact is that I just showed you that e to the r0 was equal to 1 plus EAR. So to find this, that's just a logarithm problem. You take the logarithm of both sides and then you can find R0. So that's a different approach. So then, and you know what? That's all. That's the most that I'm going to ask you to do with this. It's just that you understand that this exists because you need this for finance students who continue in finance. You need this property. You need to know this. For other students, it's just a continuation of equivalent effective rates that you need to know about. So then R0 is equal to log 1 plus EAR. So that's how that is found there. Because when you take the log of both sides, the log of E is 1, right? So that disappears and you just have the exponent. So that wasn't so hard because they gave you EAR. So anyway, that's not so hard to do. So for this one, the approach would be that you need the equivalent effective rate. So you're going to need to find I'll do it under here just like I did that one. So you're going to need to find the equivalent effective rate. So EPR 10. How do we find EPR 10? Actually, let me write it the way I did before. If I need EPR 10, and I have, or I'm given, I wrote have EPR 1 or EAR, then which one is smaller of the two? Well, 1 year is smaller than 10 years. So I'm going to make 10 of these equal 1 of these. So that's all I have to do to find the effective 10-year rate. So that's what I did in the solutions. And then I'm going to pull up the solutions. So then, once you have this, so I went through all this trouble and I got this. So it's large, right? It's going to be large because it's 15% a year, but I'm looking at 10 years. So we started with a 15% annual interest rate, and then that compounds for 10 years. So it compounds right. And it compounds for 10 years, and you just got to practice to see, like, this is it becomes 3 in decimals on your calculator. You'll see 3.045, but that's in decimals, right? So you have to times by 100 to get the percentage. So it's 304%. So 15% for 10 years compounded is 304%. So what does it mean? It means if I went from 0 to 10 years and there was 15%, a rate of 15% in every period, every year, and it compounded. So I put in $1. For every $1 I put in and I left there, let's say this was an account, it would become $304 times greater. So it become, right? So 300 times 1, or 3%, is $3, right? For every $1. So it times, yeah. Okay, so it'll go from $1 for every $1 invested, it will be $3. But what I want to do now, so the issue is, it's 304% over the total time, or I can round it to 305. But otherwise, 15% every period, every individual period. So what I want to do now is convert it into a stated rate. A stated rate is an annual periodic rate. It has to be over the year, but this is over 10 years. So I have to do the opposite, okay? Because I'm going more than 10 years, where before, I keep on hitting the home button. Before, I was less than a year and I multiplied to get to make the simple interest over a year. Now what I'm going to do is take this whole amount and divide by 10 to just get a fraction of a year. But I use division because it's the same relationship between effective and stated rates. This is the relationship. The same formula here as I used for rates that were fractions of a year. Okay, so this, you should be looking at this as though it was, if it was EPR 1/2, you would take R 1/2 and divide by 2. But now the fractions are flipped because I have more than a year, and so also the number of intervals in a year are, like here, this is how many intervals over a year, but for a 10-year rate, it's only a fraction of a year, the interval for that whole 10 years. It's 1/10 of the whole 10-year period. Anyway, you can see these are just flipped fractions, or you can think about it. So basically what I'm doing is going back to a stated rate. I just want the rate over this period, but as a simple interest. So I don't care about compounding. I don't care about all those details. All I do is I divide this 304.55 by 10 and get this answer. So it would be over the year, and I could compare that to other rates that were annually stated. So that's the same formula. Okay? So if you got all the rest and you didn't get this one, just think about this some more. Just realize I need to have the rate over a year, but I've just found it over 10. So to get it as a fraction of a year in simple interest terms, I just divide. Nothing more fancy than that. All right, so it's 7:30. Let's take a 5-minute break, and I want to go back to the notes I was covering in Tuesday's class. Okay, I want to finish those off before I introduce the new material. Okay, let's take 5 minutes. Okay, I'm back. Okay, I just got a question about the type of problems are going to be quantitative problems like the ones I've been giving you, okay? All the background reading, that's to help you prepare for the final exam and to prepare to do the MyLab finance problems. And but my tests are going to be based on the materials I give you. As a background, and for the final, you will need to read the text chapters and review them. And that's the idea of giving you access to all the MyLab finance problems in the Pearson website, so you guys can practice those, okay? So I hope that's clear. Once the test is done, you'll have a better idea what I expect. Okay, so let's continue with this. We left off, and I've given you exercises to practice, so you have problems for the weekend. After you finish this test, you have the problems in Pearson on the website, and you have my problems that I sent you. I have a feeling I'm probably going to give you an extension on the MyLab finance problems. It's probably going to happen. Maybe I'll delay it to Wednesday. I think that works out well because then you get to ask the TA and get some help. So, I'm teaching you things that you will study over the following week. So I'm ahead in my teaching, and I give you a leg so that you have time to catch up. We'll see how it works. Okay, this is where we left off. Actually, this is motivated by this slide that I didn't discuss. Let me discuss the slide here. So when I first introduced internal rate of return, I skipped this slide because I said I'd get back to it, okay? So this is, let me recap what we did and you'll see the context. So we learned about different ways, different techniques for assessing projects, investment opportunities from a firm perspective, okay? From a managerial perspective. And we started with a discussion or a review of NPV, and NPV was in dollars. Then we went to payback period rule, and that was in years or some period of time for the project to recover costs of your investment. And then I talked about discounted payback period rule, and that's also in years or some sort of period of time. This is the one from last class, 3.1. Thank you, Senna. And then we talked about the internal rate of return. An internal rate of return is a percentage. Okay, so there are different metrics, different measures to help you make your decision, and they have different advantages and disadvantages. When it comes to the internal rate of return, the greatest advantage is that you get a single number as a percent. Actually, sorry, you get a range of values as a percent. So it alleviates the necessity to have a discount rate predetermined as the NPV would. So it's an improvement on the NPV in that way that you don't have to have just a single required rate of return to analyze your projects, an interest rate for the formula. You get a range of values that would be acceptable for you to pursue a project. Okay, so let's see what I have to say here. So the internal rate of return It's the discount rate that sets the NPV to 0. So it's the discount rate for break-even project. We make, in the process, we've been doing this, and I haven't said anything, the reinvestment assumption is that the IRR calculation assumes that all future cash flows are reinvested at the internal rate of return. Okay, so that it's the same rate over time, and it's the rate that is the break-even rate. We've looked at independent projects, and we are saying for investment projects, you should pursue the project, accept it, as long as the internal rate of return, the return on the project, exceeds the prior required rate of return. Okay, so as long as you prescribe, you do better than you require as a return, you should pursue the project. And it's dollar return we're looking for, net present value, dollars. What's wrong with this? And actually, these disadvantages, we've resolved some of these issues. One was, it does not distinguish between investing and financing. And I taught you how to distinguish, with the first cash flow being a positive and subsequent cash flows being negative. That's a financing project, and the rule flips. You interpret the internal rate of return as a borrowing rate, which you want to be lower than the discount rate. Here you want the return to be higher than the required rate of return or the discount rate that you use. IRR may not exist, or there may be multiple IRRs, and I explained how to deal with that as well. So that's not really a disadvantage anymore. And this is the last disadvantage we're going to look at, and I'm going to resolve it as well, the problem with mutually exclusive investments, because all we've talked about so far are independent projects. Okay, so what's the advantage? It's easy to understand and communicate. It's a rate of return on investment that you can compare to your required rate of return. So let's look at mutually exclusive projects now and how to handle those. So here I'm going to explain why there's an issue with that. First problem arises, or some problems arise, because of a scale problem. Here's an illustration to help you understand what exactly the scale problem is. Which one would you pick if I was to offer you opportunity 1 or 2? Number 1 is invest $1 now, and at the end of the class, you will get from me $1.50. Okay, so I do an e-transfer and send you $1.50. Or opportunity 2, where you invest $10 now, give me $10, and at the end of the class, I will give you $11. Okay, so I've given you 2 potential opportunities, and they can be related by the fact that one is considered a higher budget project. It's a higher investment for a higher return relative to these. This is lower budget project, $1 to get $1.50. So which one would you pick? How would you make your decision? Would you pick opportunity 1 or opportunity 2? So which one would you pick? You guys are stumped, or you're distracted. So how many of you would pick an opportunity 1? I probably should set up a clicker response. That would be faster. But okay. What are the issues here? Well, if you invest $1 now to get $1.50 back, you're getting a 50% return. So that would be, you're analyzing it as though it's a IRR when you think about that, right? But the second project is only giving you a 10% return. So that gives you a sense of, what IRR is. It's, for $1 you're getting $1.50. That's 50% more. That's what that represents, the IRR. So this would tell you, if you were to use this internal rate of return rule to pick between them, it's telling you to go to alternative 1. However, if you use the NPV rule, so the way to use the NPV, I had to pick a discount rate, right? I have to put in a discount rate myself, or a required rate of return. So I'm just going to use a small number. I don't know, just threw it in. Say that there were other opportunities available in the 1.5 hour class or the 3 hour class, and I used 0.05%. So I just threw that in just to make the calculation. And you see here, the second one gives you a higher NPV. So if you were to rank these to compare which one is better, this is telling you to pick 2. So we have a problem. This is inconsistent. As you've seen before, IRR and NPV should coincide. They should give me the same answer. So when they don't give me the same answer, what do I do? Which is the right answer? It happens to be the case that NPV is always the right answer. We use NPV. Remember, IRR, when we have conflict, we turn to the NPV to decide which is the acceptable range of return, right? So in this way as well, when we have conflict, we will turn to the NPV when we conduct mutually exclusive project analysis. Now, so what's going on here? What's going on is that one assumption we've made this whole time, being able to choose between 1 and 2 implies that you must have $10. So if everyone has $10, it's better for you to invest to get $11. So opportunity 2, I'm saying that wrong. So if you have $10, so we've assumed in 1 and 2 that you have up to $10 to be able to invest 10 to get 11. However, you're getting more bang for your buck if you invest 1 now in opportunity 1 to get $1.50. That's what it seems like if you choose the IRR rule. So you have a conflict of percentages versus dollars. You have a conflict between whether you should care about the percentage return or the dollar return. What's actually in your pocket in cash flows, however, is the better return. Okay, so if you actually have $10 in your pocket, it's better to get $1 back as opposed to 50 cents. Okay? The problem here is that this is giving you a relative measure, but we need to care about the absolute. It's a difference between relative and absolute. Okay, relatively speaking, number 1 looks better, but if we have the opportunity for number 2, in absolute terms, we get more. We get $1, not 50 cents. So anyway, whether you understand that or not, the point of this is that NPV gives you the right answer. Okay, not IRR. A second problem where IRR seems to fail you. This is known as the timing problem. And we saw something like this before. When I showed you in multiple internal rates of return, you saw that low and high discount rates were favored over in-between rates. So here's an example like that where for this project favors low discount rates, a low required rate of return, because it wants to retain the value of the $200 coming at year 4, by the end of year 4. That would make the NPV higher for A. But the second project that I'm comparing it to, where the cash flows were determined, this one favors, it doesn't care really if the internal rate of return, if the required rate of return was high, because it comes early on and it won't erode the value of this amount. Okay, so the first project likes low discount rates, but the second likes high discount rates. That'll make the NPV of B greater. So in terms of NPV, it depends. Sometimes A is better than B, and vice versa. If we were to calculate the IRR for this exercise, and notice how I do that. This is, I want you to write this up properly, and I give you many examples of that. You see, you have to put 0 equals the whole expression with IRR. So for the test situation, we'd write all this, and then show me your answer. This expression does not equal 12.91. Okay, this expression is solved to find IRRA, that's 12.91. Okay. Similarly, this other one here. So when I calculate the IRR, it looks like an IRR, let's say these are investment projects. You see, negatives first and then all positives. So these are investment projects. It means that I want the IRR to be bigger than the discount rate. So if I was to compare or rank these, this rule, IRR, is telling me to pick B. So what do I do with all this information? The NPV is saying it depends, and IRR is saying pick B because it has a higher return. So how do we put this all together? Okay, I'm going to illustrate the problem with a graphic. Here it is. Those same cash flows are here. What I have drawn here is the internal rate of return for project A. For these are the cash flows. Remember how we did the NPV profile. This is the internal rate of return here for the NPV profile of project A, and this is the NPV profile of project B and its internal rate of return. What do we see? We see the depends on this point, this crossover point. So it says that the NPV is higher. Notice this is NPV, remember? So NPV is higher for project A up until here, and then it switches. then the NPV is higher for project B up until here. After here, you shouldn't even conduct either of these projects, okay? Because the NPV will be negative. So, what we're going to do is analyze what's called the incremental project. We're going to combine these profiles to create something called the incremental project. I'll just call it A over B. This is project, let me write that again. Project A over B says pick A instead of B. What I'm going to do is take A minus B, A's cash flows minus B's cash flows. So 350 negative minus negative 250 gives you what? Negative 100. Then 50 minus 125 is negative 75. This one is 0, this one is 75, and this one is 150. So what you have is, this is called the incremental project. Okay, what do we do with this incremental project? Now this is the project we're going to analyze. So we don't look here anymore. We've combined those. They've collapsed into a new set of cash flows. And it is a negative and a negative and then positive. So it's kind of like an investment project, right? It's all downsloping. So on the next slide, you see that. The bold line is the incremental project. And what does it say? I left the other two on there. And it shows you, if you enter these into your calculator like we did the other day, you will be able to find the internal rate of return for the incremental project, which is the same as the crossover rate. And what it says is exactly what we said before, but in it's exactly what I said earlier, that we would pick A up until this point, and then otherwise we would pick B. So this says the exact same thing. It says conduct project A instead of B. That's what A over B means. As long as the discount rate is smaller, or as long as the required rate of return is smaller than 8%. Otherwise, pick project B. It doesn't actually, it just says do A as long as the discount rate is smaller, right? Because that'll give you a positive NPV here. So that's what I say in the notes. Accept the incremental project A over B means do A, not B, provided that the required rate of return is smaller than 8.07%. So as long as the required rate, if it was 5% and this project returns 8%, then you should do the project. What project are we talking about? We're talking about doing A and not doing B. And still, just like before, we've collapsed these cash flows into a new set of cash flows that we interpret as A instead of B. And we proceed to analyze it as though the incremental project is an investment or financing or multiple IRR project, depending on the pattern of the incremental cash flows. So I actually gave you some problems with answers to solve problems like these, and you'll need to look at those. I don't know if we should pull one up. We'll do one together. But you have all the solutions. I shouldn't have given you all the solutions. But let me see. So why don't you look at hold on. Okay, there's 3.6. Let's look at 3.6. Go to 3.6. This is the problem. This is document 3.6. And I ask you to determine whether either one or both of two independent projects should be recommended. You are informed that the effective annual required rate of return is 10%. Cash flows for the projects are indicated in the table below. So you have project A and project B. Don't look at the answers. Hopefully none of you looked at the answers already. And try this problem. I ask you to calculate the IRR for project A and calculate it for B. And according to your calculations, what would you recommend? A, B, or both? Okay, I'll give you a few minutes. Try that one without looking at the answer. All right, I'm back. All right, you wrote all kinds of things. That's good. So here's what you do. Ask you to calculate the IRR and then evaluate. If you calculate the IRR, and please, I'm giving you the solution here, but practice writing it up because you're going to have to write it up. It's you make the expression for the NPV equals 0, and then that gives you, from your calculator, an IRR of 7.6347. 7.6347 is not greater than the required rate of 10%. So the project is not does not meet the criteria. Okay, so it's not a feasible project. We're not interested in the project. Do not accept project A. The evaluation we conducted was because project A was an investment type project. We're confirming that the return, the internal rate of return was higher than the required rate. And in that case, we should not accept the project. In project B, it's not an investment project, it's a finance project. It's a finance project. First one is a positive, the rest are negative. You make an expression and determine that the IRR is 0. Now, how do you interpret that? IRR is 0, well, that's the borrowing rate. Now, it's saying that there's no cost to borrowing. Okay, remember, we interpret from a finance project, the rate that it returns is like the rate of borrowing that money up front, or taking that money up front, taking that loan, or taking those funds. And we want that to be low, less than required rate of return. Since it's the best you could do, really. You accept this project. Okay? So that's how you would evaluate. That's how you would evaluate them, because they are independent projects. That is said in bold up here. Okay? You should have the same answers if you calculated the NPV. So notice I could do both if they were both feasible, but the first one isn't. Okay, so calculating the NPV, write out the expression for NPV, and then the result, the NPV was negative, so we should not conduct project A. Okay, so NPV required that we know the discount rate that for our formula, and we calculate it. And with our calculator, we get a negative. Do not accept the project. For project B, we get a positive NPV, so you should accept the project. Now, if I was to ask you to analyze these as mutually exclusive projects where you can only pick one, notice we have in the cash flows, you have a scale problem because these are all low numbers and these are high numbers. And you also, no, you don't have a timing problem, It's a problem of scale because this is a high budget project and this is A is a low budget project where B is a high budget project. So you may risk having conflicting conclusion or like a relative conclusion depending on what the discount rate is. So if I was to only pick one of the two, well, because I've already conducted this calculation in A, I know that part A, I know project A is not feasible, project B will be, so it's probably going to be the same result, but I want you to analyze this as though you never did part A. So if you never did part A, you would conduct an incremental project analysis. You subtract. Now, how do you subtract? Usually I'll tell you how to subtract. Usually I'll tell you how to subtract, but my tip is subtract them so that the first one is a negative. So it turns out to be, well, let's say, if it's up to you to subtract them however you want, make the first one a negative so that your interpretation is as though, well, it might be an investment type project. In this case it is. So the incremental project of A instead of B turns out to be incremental. Turns out to be like an investment project just by chance that these are zeros. Positives. Sorry, I was reading some of the texts in the chat. Right, so an investment type project is where you have a negative first and then positives. You need to read the notes again, okay? Because it's, I've said in the notes, and I also prepared a summary sheet with those things. So put all your summary sheets together and read them tonight before you sleep, because I summarize all this stuff. A finance project is where the amount is positive, the initial outlay is positive, and then the other ones are negatives. And it results in the incremental project being an investment type project. So we'll evaluate the incremental project as an investment type project. You could do this computing the NPV, which will give you the right answer. And it'll help you make the right decision. So this shows you if you did A minus B. Remember, we didn't choose A, right? A is not a feasible project. So the analysis of A over B says don't accept A over B. Don't do A instead of B. That's what it's telling you. I say do not pick A instead of I'm going to write in cursive. I hope you can follow. Okay, do not pick A instead of B. And so you can flip it and say don't do A instead of B, but you can do B over A. That's pretty much what it says. It's not A over B, it turns out to be B over A. You can check that too. You can subtract them the other way and check and verify that you'll get a positive NPV of B over A. What about if I conducted this with the IRR? So here's I'm showing the expression for the internal rate of return. Notice what I expect you to do here, okay? Write it out very nicely and then use your calculator and tell me what it is. And what does it say? It says the internal rate of return is 0.3126 for A over B. Since it's an investment type project, negatives and then positives, this is supposed to be higher than the required rate, but it's not, right? So you don't accept A over B, or in other words, do B instead of A. So if you have to pick between them, using this approach, you'll get the right answer. It'll tell you what to do. Whether you use the IRR or the NPV, it'll give you the same answer, okay? Because you've calculate the incremental project. Okay, so that's something for you guys to look at. I've given you exercises to practice. Continuing with the notes. So far we've learned about the NPV, which gives us a dollar amount. We've learned about the payback and discounted payback period rules, which give us a time period in years or so. Then we talked about the internal rate of return, which gives us a percentage. And I discussed the advantages and the potential disadvantages of the IRR and how to resolve those issues. And it looks like when we use the IRR, we are depending or leaning on the NPV. So from all of from all that we've studied, we've understood the advantages and disadvantages between the different techniques. There's one final technique I'm going to talk about, and that's known as the profitability index rule. Okay, so this gives you a ratio. Okay, so we've seen dollars and years and percentage, and this is going to give you a ratio. The ratio is a different way of seeing the benefits, the investment or the cost and the return. The investment here now is not at the beginning of an equation like in the NPV or the IRR. The investment is on the top of the ratio, and on the bottom, the investment is on the bottom of the ratio, and on the top we have the return. So we have return per dollar invested. That's actually what it is. What is this thing here? NPV plus CO. These are the future cash flows. These are the future cash flows. So the present value of the future cash flows. That's what that is on top. And on the bottom, we have CO, the initial investment. What is CO? Just to be clear, since CO is a negative cash flow, I use the positive version of it. So CO is the positive version of the initial cash flow. Okay, and what do I do with this number? I'm going to compare it to 1. If I get more for every dollar I invest than $1, I'm going to accept the project. Again, we make a number of assumptions to come up with our future cash flows, and the timing of the cash flows, the amounts of the cash flows. So we use like our own version of a crystal ball to come up with those, and then we calculate the present value, knowing the techniques, the time value of money, basic time value of money formula, or you can do it with the NPV. And then what you're doing is adding back the initial investment. So this gives you the present value of future cash flows, all right, by doing it this way. And then dividing it by the initial investment. Okay, so this should be greater than 1 if you're evaluating a project on its own account, just deciding if you should accept or reject the project. If you have many projects to choose from, and you only get to pick one, you should pick the one with the highest profitability index, okay? What's wrong with the profitability index, or what are the disadvantages? It's going to be the same when you analyze mutually exclusive projects. It's going to give you the same problem in terms of scale and timing, so you'll have to instead evaluate the incremental project, okay? What are the advantages? Well, again, it's a ratio. It's easy to understand. You say for every dollar invested, this is what you get. So as long as it's more than 1, then you got your money back and some. It'll give you the correct decision when evaluating independent projects. And there's going to be one added bonus above the other kinds of rules that we're going to discuss. It may be useful in evaluating, efficiently evaluating investment alternatives when you have capital rationing. Remember, I mentioned the 3 kinds of things we were going to look at the beginning. When you have enough capital or money to invest in more than one project, but not all of them, we call that capital rationing. Okay, so Michael asked, is it okay we just use NPV because it's so great? You need to know all the techniques, okay? Because remember, what's the problem with NPV? What's the problem with NPV, everyone? I mean, it does seem to work, and it seems like we fall back on it, but what's the problem with NPV? What's the problem with NPV? The problem with NPV is actually, I won't write something new. It's already in the notes. What's the problem with NPV? I go all the way back. Oh, I don't say it, do I? It's funny. Well, the issue with NPV is, this is back to page 3. The discount rate that you use to evaluate the NPV must be determined, okay? And sometimes you just might not have it. You have a kind of an idea, but you don't really know what it should be or what's the right one. And by using IRR instead, you just avoid the problem because you don't have to have a discount rate. You just have to have a rough idea of it. Okay, so that's the problem. A limitation, let's say, or disadvantage of NPV. That IRR alleviates that burden. So this is why we're doing all of these things, because of that limitation. Okay, so let's go back to the profitability index. Let's calculate it. Here's our exercise. Here's a project, project Y, an initial outlay of $1,100. And here's another term for discount rate or cost of capital. So I mentioned these terms are all the same thing, right? So hurdle rate or required rate. So hurdle rate, like, you know what a hurdle is, right? When athletes run and they have to jump over that structure, that's called a hurdle. So this is what you have to reach over. So it's the required rate of return. Just another word for it. You can also, it's called cost of capital or opportunity cost. Okay, these are all the same term. It's the implicit interest rate for our calculations. So I give you a simple problem, 2 cash flows. What's the NPV? And then find the profitability index. So if I calculate the NPV using my calculator, I get, so I write this out for my test situation, right? And then use the CF keys to find the NPV. Now with that, let's get the PI. So PI is, you put the initial investment here as a positive, and then on the top, you add back the initial investment, so you just have this part. That's all that you want. So this part is just this. You guys are frozen? Okay, let me reboot. I'm gonna reboot, it froze. I think I lost the internet on my iPad. I don't know what happened. Something. Give me 5 minutes. I'll try and fix it. Okay, it's less than 5 minutes. I'm back. Sorry. All right, let's go back. Okay, so what I was saying was, I guess we got up to here, I circled something above. I don't know what you guys were looking at. Where did I leave off? Here? Page 18. Where did I leave off? Okay, so I'm back here with the PI. And what I said was about it giving you initial outlay and then a hurdle rate. And I referred to the hurdle rate as the required rate of return or the cost of capital. They mean the same thing. So, hurdle in races, running races, are obstructions that you have to jump over, okay, if you're running hurdles. I was good at hurdles. So you have to jump over this obstruction. So in the same way, the return on this investment should exceed this amount. So that's the required rate of return or the cost of capital. They mean the same thing. Okay, so these are the annual benefits estimated, the $500 and the $1,000. So to get the NPV, you write it out for a test situation, and then you can put it in your CF keys of your calculator and get the answer. It's $180.99. Now what we want to do for the PI is we want on the top the present value of future cash flows. I just want this. But it's easier to take advantage of the very simple calculation the NPV did. And my calculator made that calculation. And then add back the initial investment, so I can just get these two together. So that's these two together. And then divide by the initial investment as a positive, not the negative cash flow. I want the positive amount. So what I'm comparing here is I'm not subtracting them, I'm dividing them. The return divided by the investment. So I get a ratio. And as long as the ratio is bigger than 1, I should invest. So I got more for every dollar invested. I didn't just get my money back. So when we divide, you're scaling it, you can interpret this as 1.2 over 1. So for every $1 as a ratio, every $1 invested, you get 1.2 back. Okay. So this is a point I want to make. Now, the advantage of the PI is that it easily gives you the right answer, or by just calculating the PIs and ranking them. When you have to choose from several projects and you could accept more than one but not all because of capital rationing, limited funds, PI will give you the right answer. So here's an example, okay? So here we have project 1. Here are the cash flows for project 1. Negative 20, 70, and 10. Project 2 is negative 10, 15, and 40, and project 3 is negative 10, negative 5, and 60. So you can think of those as millions of dollars, right? So I put it here, a note, in millions of dollars. So we're asked to choose between projects. These are 3 possible projects, and we have as much as $20 million to invest. Which projects should we invest in? What are the options? Either project 1, because that costs $20 million up front, or 2 and 3 together. So I've given you some numbers here. I've given you the NPV of each. I've given you the PI of each. And I've given you the NPV adding back the initial investment. So this is like 50.47 million. And I'm adding back 20 million to get 70, you see? And this is 35.28, adding back the 10 to get 45.28. And this is 33.37, adding back the 10 to get 43.37. Okay, so I have... I use the NPV to calculate the PI that way. So, looking at this, what should I do? Should I use the NPV? And I see here that clearly project 1 is better than project 2 or project 3. Or do I use the PI and I see if I rank them, it looks like project 2 is better than project 3 and project 3 is better than project 1. So that implies I should do project 2 and 3. So which one, NPV or PI, tells me what to do? And could we modify something here to help us make the right decision? So when capital rationing, PI easily gives you the answer, okay? In terms of NPV, you would have to make a second calculation. You would have to use the NPV properly, you would have to calculate project 2 and 3 together, get a whole new set of cash flows, and calculate the NPV, the future cash flows, and then the PI. And that would show you that 2 and 3 together has a higher NPV than just project 1. But if you were just going to do it this way by calculating individual projects, the PI is the one that gives you the right answer. Exactly, Spencer. Right. Okay, so PI, it's a calculation that, when you know this, can make your decision making much more efficient. You just calculate the PIs and you see the PI of 2 is greater than 3 is greater than 1, so pick the top 2 and you're done. If you did that with NPV, you would be on to the wrong track. You would actually have to calculate 2 and 3 together, and then that would show you that 2 and 3 was better than 1 alone. Okay? If you did the same thing with PI, you would still get the same answer. So PA is an index of bang for your buck. It shows you what you get for every dollar invested. All right, so as a final statement regarding these notes, what do CFOs use? Chief Financial Officers, what do they use in their departments? So when asked, 75.6% of them said they use the IRR. So as I explained, there is the advantage on top of the NPV, because you're not bound to a discount rate in advance to make a calculation, okay? Although NPV is a close runner-up, the payback period rule, notice, is more popular than the discounted payback period rule because its very nature. The idea of the payback period rule is, people asking potential investors or superiors or shareholders are going to ask, when do we get our money back? When do we recover the cost? So they'll just use the values as they are to make that calculation rather than discounting them and going through the trouble. It's just a back of the envelope quick notion of when we get our money back. And that's used half of the time, okay, by CFOs. So you notice the least used is the PI. It doesn't mean that it doesn't have value. It doesn't mean that it could be used efficiently for capital rationing decisions. That's all true. But it seems that CFOs really like the IRR because of the power of interpretation. You have a range of values to play with and decide, well, as long as we would choose a required rate of return between 10% and 20%, we're okay. And usually we, for these kinds of projects, we use 15%. So it leaves them room to make a decision and not be bound to a discount rate. And that's why they like it. Okay, so PI suffers because you have to actually have a discount rate to calculate PI, just like the NPV. So there you go. This paper was published about 20 years ago, and it would be interesting to know if this has changed. But there you go. Okay, so I am done with these notes. This is module 3. This is just a matter for you this weekend after you finish your test. Look at these notes. I'll extend the deadline for your MyLab Finance to Wednesday again. I think I'll just change them all to Wednesdays. That way you can see the TA in the evening and then, finish as much as you can and then ask the TA certain questions to help you wrap up your assignments. Do you have any questions about Module 3? It's going to take time. So the question is, what should we choose? For this class, this is your first corporate finance class. You just do what I tell you to do, okay? So if I tell you to calculate the IRR, you calculate the IRR. If I tell you to use NPV. But in general, you need to know the advantages and disadvantages of the alternatives. So read through the notes, get familiar with them, watch these videos again, or ask me questions if you want me to clarify. But I would use the IRR if I was making calculations. However, I'd also probably present all three of these: IRR, NPV. So you use the IRR to get a range of values. Then you can calculate the NPV with a select discount rate just to show people who you have to convince about investing in a project. You'd show them the NPV. They could understand a dollar return. And then the payback period rule will reassure them of, you're going to get your initial investment back in this many years. So that would be good. Yes, exactly, Spencer. You'll probably have more questions later. So work with this material, and that's fine. I gave you a lot of stuff to work with. Try not to look at the answers, just answer the questions as you go. And then look at the answers. So that's what I'm going to do. That's for that. So what should I do in this next, I have 45 more minutes. Do you want me to solve more problems for the test, or do you want me to get on with the next module? I have to send it to you. Okay, you want some more questions? So tell me which ones to do. Tell me which ones to do. Let's see. Go back to the test prep. Okay. Okay. Tell me which ones to do, because so you said stocks and bonds. Okay, let's see. Oh, I referred to in question 15. Okay, so differential growth model is just where, I guess I don't have an example, but the idea is, yeah, it's unfortunate that it sounds so formal. It's just that you have different rates of interest over different periods. So let's do this one. I think I had examples in my notes, but yeah, let's do this one together. Okay, so Regency Candies shares, so this is, I have the wrong, hold on a second. They have the wrong heading on them. Anyway, okay. So, shares a 7.5 annual dividend per share this morning. The company is going through rough times, and its annual dividends are expected to decline at an annual rate of 3% every year for the next 10 years. Following the annual dividend 10 years from now, the dividends are expected to stabilize at a constant level for 20 years. And finally, following the annual dividend 30 years from now, dividends are expected to grow at an annual rate. Okay, so this is just differential growth. Like there's different growth rates, there's different periods of of growth. And then we come up with an indefinite figure forever. Okay, so it's just the growth changes. So you have to partition the problem and add all the pieces together. So let me see. I'm going to So there are three different periods of growth. The first is for okay, so The interest rate the whole time, the discount rate that you use, or the interest rate for your formulas, are 15%, right? Because it's an effective annual rate. And payments, so payments are annual. Right, so payments are annual. That makes things easier. So because payments are annual, I use the effective annual rate of 15%. But there's differential growth. So for the first 10 years, G is equal to negative 3%. It's just a fancy word, differential growth model. Don't let it throw you off. Negative 3%. And after that, it stabilizes. So when it stabilizes, there is no G. Okay, so there's no G. G is 0, or it's just like an annuity in here with no growth. And then, so G is equal to 0, but you don't put that in the formula, so I'm not going to write that. So I'm just going to say no growth. So that's up to 10 years. Oh, let's use a different color. And then that's for 20 years. So we're going to end up now at 30 years. So after the 30th year, they grow at 8% forever. What a great company to invest in. So G is going to be 8% as a positive. So if you hang in there, it's going to decline for 10 years and then it's going to go up. So what's really important is the pieces here. In this range, I'm going to have to expand this. I'm going to have to go. So all I really need for my formulas are the first two cash flows, right? Let me make this bigger. So this is 0. Or this was 0. So this is 0. And then the first cash flow at the end of the first year. So since it was $750 initially, it was $750 here. The first one is going to be the one we get if we're looking at valuing it here. The first cash flow is $750 and it's grown by a factor of, well, actually declined, of minus 0.03. That's actually what it looks like. In other words, it's 750 times, plus minus 0.03. So it's really 0.97. Sorry for the confusion. Okay, so that's the first one. It's lower. It's going to be lower. So if you work this out, this actually comes to, if you want to write it down like this, 7.275 is the first. So for every share, you earn $7 and 28 cents. Then what happens is that these are growing. So the second one will grow, the third one will grow, the fourth one, fifth one, 6, 7, 8, 9, and the 10th one $10. Now you have to think about what will be the number here, because I need it for the next set, the next annuity, so, or perpetuity, or whatever's coming next. So I need to know this one. So if this is one factor of growth, and this is 2, 3, 4, 5, 6, 7, 8, 9, 10, you see? So this one will have the value 750, 0.97 to the power of 10. And why do I know that? Because there's a 1 here. You see, this is a 1, and this is a 1. So this has to be a 10 for the pattern, and that has to be a 10. So this happened because, remember, there's growth all the time. It's not precisely like the growth formula we're used to. So all we need for our formula anyway is the first cash flow. And then you have to be careful. This would be 750, Since what I need is the first cash flow for the formula, this would be 7.275 times 0.97 to the power 9. You see? Because for my formula, remember the formula. Remember the timeline that matches the formula. The timeline that matches the formula looks like if it's growing annuity, it will be C1 and then C1 1 plus G. You have to stick to that pattern in order to use the formula. So you need C1, which you can write as this or as this. But the reason why I'm writing it like this is not to confuse you, but to show you this is like C1, and then this goes on until this one at the end, where I use the same C1 times a growth factor that goes with it. So then what happens? So what happens next is we get into the next stage. So in the 11th year, we're told that it's going to remain constant, right? So it will be this amount or this amount. They're the same thing. So I could just write this one, and this just goes for until 30. So between 11 and 30, it's always going to be this thing, 750.97 to the 10. I'll write it like that. I just think it's more intuitive. 750, 0.97 to the 10. And that's going to be, that. Let me write it lengthwise. Or you know what? I'm going to write it like this. 750 0.97 to the 10, and this one will also be all the way through the same 750 0.97 to the 10, all the way through. Got it? So this is my timeline. I still have one more set to go. So in here, these are what it looks like. It's a growing, so in here, it's a growing. Even though this is for stock valuation, because it's differential growth, because the G changes, I chop up the terms into blocks of time. So the first 10 years at a growth rate of -3% is one growing annuity, where the first cash flow is this, and then there's so there's 10 payments where G is -3%. And that's it. In the next block of time, and these are like dot, dot, dot. In the next block of time, so all I needed was for the next block of time, I had to figure out what the first cash flow was, and I know that. Now this is just a regular annuity. So this portion is a regular annuity. There's no growth here. And then the last part is a perpetuity because it goes forever. So all you need to know is what the first payment is. It's growing. So it's a growing perpetuity. And it's going to be 8% forever. So let's just write that part out. That goes on forever. And the first one will be, so after the 30th year, dividends are expected to grow by 8%. So the first one is going to be higher by 8%. So the first one will be this, but because growth of 8% happens after 30, the first one would look like this, 750 0.97 to the 10 times a factor of 8%, just one. That will be the first one. And that's all I need, because then I use this one. So this would be the C1. This is like the C1 for the third part. And this would be the C1 for the second part. And this will be the C1 for the first part. I'll use this version because that's what I did in the solutions. This is C1. So what you have are three portions. This is a growing annuity, this one is a regular annuity, and this one is a perpetuity. All you need for the formula is the C1, and that's all I've done. I made this messy thing just to show you how I compute the C1 each time. Are you guys blown away? So I've got the C1. So now what do I do? So I got all the C1s. I made my extremely long timeline. You guys, the test is open book, so I need to be able to expect this. You should be studying, and then when I give you the questions, they'll be they'll be of the same difficulty as these. But because you've rehearsed, hopefully you've been practicing, and it won't be like you've seen them for the first time. They're going to be different than these problems, but similar. I don't know how else to say it. So what do we have here? So we have a growing annuity here with the first cash flow this. So I'll show you that in the formula. Then we have a regular annuity here. And then we have this perpetuity. So what we have to do is discount all these portions. This one has to go all the way back. This one has to go all the way back. All of them have to come back and be evaluated at time 0. So I do that so all these numbers should be familiar. Let me flash up the solutions. So yeah, this is a longer type exercise. So here you recognize some of these numbers. So this is what I did. The first 10-year was, remember, negative 3%, and the first cash flow you could write as this or this or this. The second group of years starts with the cash flow 750.97 to the power of 10. The third group of cash flows, where it starts at 8%, the first one looks like this. So we saw all that. Now what? Now I'm going to discount them all back. The first one is an annuity that's growing. Remember this formula? This is the growing annuity formula for 10 periods. That's all this is. The second group, ignore this for a second. Ignore this for a moment. And what you have here is the annuity. This is the first payment of a regular annuity for 20 years. I have to do this because it starts on year 11, remember? So it starts on year 11. Remember, the annuity formula gives you the value 1 year back. So this is the value at year, so this is PV 10. So I need to discount that back to time 0 by using a discount. So basic time value of money discounting back to time 0. Finally, the 8% kicks in. This is the first cash flow, and it's a perpetuity. Very simple perpetuity. And I could say the same thing. Just forget about this moment for a moment. So this is the perpetuity formula. You see it, growing perpetuity formula. Let's be clear. So it has to be, remember, the growing perpetuity is C1 over I minus G. So there you go. And there was a stipulation that I had to be greater than G. And it is. And that starts at year 31. So that gets discounted back to, that's going to be PV 30. So I need to discount that 30 years. So as much as this is long, if I could make 3 questions of this, but because I'm forcing you to add them together, it just seems a little more intimidating. But it's not. You could do all of these separately just fine. I'm just asking you to add them together now. So you take care, keep your decimal places, use your storage keys, and add them together. This one you have to punch in. So this is a good exercise for practice punching in values, because you have this growing annuity here. So what can we do here? Should I give you some time to punch it in? Or you'll let me know. Do you have problems with the concept that I can help you with? Okay, Kyla asked me a question. Is chapter 1 to 7 and the first test the biggest chunk of the material learned in this course? No, unfortunately, it's not. It just continues. The intensity continues, Kyla. It's just like there was many chapters. They have like divided them up into many chapters, but you just have more chapters in the text for this unit or this portion of the course. But yeah, there's every week has equal intensity of material. The only thing I would say is that the skills you learn in week 1 you'll use throughout the course. Some of the things we learn, like discounted payback period rule, I'm only going to ask you for week 2 test. And then it might come up on the final, like you're not going to use it all the time. Okay, Senna is asking for both bonds and stocks, the growing annuity and perpetuity formulas are applicable as long as we have the proper interest rate to match, correct? I'm not sure. For both bonds and stocks, the growing annuity and perpetuity formula. Well, for bonds, we just use we don't use growing annuity for bonds. We usually just use the regular annuity, right? For the coupons and then the time value of money. Not sure about that question. But the interest rate that you use has to be matched to the timing of the payments. That's the important thing. Kyla, why are we multiplying the 7.5 by 0.97 if we already accounting for the... Oh, because the first one also experienced... Let me get it. Hold on. The first... So it's kind of invisible there, but I did write it. Oh wait, I want to get it here. So notice for the first one, the formula is accounting for it, but for the formula I need the first C1, the first cash flow. And growth happens here. With the formula that I taught you, growth doesn't happen there. The formula that I taught you, growth happens here. You see? So the formula that you know, the growing annuity formula or perpetuity, the growth happens here. But in what we did with this problem, the growth happens here. So the adjustment for that being wrong is I have to figure out the first cash flow and then I can just apply it because growth happens here too and continues. Is that okay? Okay, so that's why. The formula requires that I have C1, so I need to get it. I have to find it. Knowing about the initial dividend, knowing about the first dividend here, and knowing about growth that happens here, I'm able to find this. That's what I'm doing up here. I wasn't just given C1. I had to determine what it was. Okay. Okay. All right, 10 more minutes. You want to do a bond question? Right, Kyla. So it assumes, right, always assume, well, not right, but we always assume that the dividend that comes today, so the idea is what we're doing is we're valuing stock as though we were buying it today. So because the dividend comes today, we don't get it. That's how we value it. Okay, we evaluate shares, we value stock as though we don't have it. Or we're just going to buy it today, so we don't get the dividend today. We get the ones that are coming. Okay, number 14. Okay, yes. Yes, you are missing something. I haven't even read the problem. Okay, but you're missing something if you... Oh, why is N40? Oh, okay, yeah, you're missing something. So what happened? Okay, all I've said here is the face value is 1,000. The term to maturity is 20 or 20. The yield is 8. No coupons. So when it doesn't say anything, it just says bonds of comparable risk have a yield to maturity of 8%. You have to treat that 8% as a stated rate. That's what you're missing. So bonds always are stated rates unless I tell you a different number. Okay? Unless I say it's effective. So that's why timing, so this tells you, so for bonds, okay, let's write this clear. So bond returns so hard. Returns compound semi-annually. Okay, so it's semi-annual. But it's stated annually. So you have to convert the rate I don't know, because it's zero coupon, I'm seeing what you're saying. If you just use the 8%, but let me see what I did here to confirm what I wrote. Yeah, you have to convert the rate to get the right answer because compounding is semi-annual. Yes. Okay, so you're always getting an R1/2 from bonds. So you won't get the right answer unless you take that account, and then from here you know EPR 1/2 is half of that, so it's 4%. For people who are still learning this, that's the conversion. Right, from stated to effective rates. Now you can make the calculation. What is a bond? So you have to write out the expression, but there are no coupons here. It's just going to be a pure discount bond. So the present value is just the $1,000 that you get from 40 periods. So 20 years is equal to 2 times 20 periods, or 40 semi-annual periods. That's semi-annual SA periods. And that will give you the right answer. That's different from if I put 8% in here with 20. It's going to be a different number, just because of the compounding. Okay. Yeah, I know it's probably confusing, but yes, if it doesn't say anything, for bonds, it's always R1/2 that they give you. If they don't say anything, mortgages are always R1/2. So you need to convert it. That's the longest conversion. You have to convert it to a monthly rate. It's kind of brutal. Okay, you guys keep practicing. What else? I know you probably want to go because it's late. Anything else? Do you want me to be available to you again? I don't know. You know what? If you have a question, send me an email, and if you need to talk to me, I can give you a call. Either I can explain it on the phone, or I don't know. Maybe it's just something simple. I'm hoping, because I've given you the full solutions, and most of the things I'm explaining now, you guys seem to be getting, or the people who are asking seem to be understanding. So maybe we can just do it on the phone. So let's go with that. The test is in 2 days, but you do have all your materials to work with. Just try and iron out questions. You can't ask me questions during the test unless it's a clarification issue. You can text me and I can call you. You guys have my number, right? You wrote it down. Bonds are always R1/2. So this document that I gave you, this one, wait a second, what did I call it? I lost it. This one with the credit card. So 2.2. In 2.2, you have all the assumptions, or the credit cards. You see, credit cards are always R1/365. Mortgages, in the US, mortgages are always R112. Stock are always, well, not always, but they could be stated. It'll have to say in the problem if it says it's a stated rate. This is not a given. I give you a lot of problems, and I say that rates are effective. So this is not necessarily the case. But for mortgages, and you have to remember this, mortgages are R1/2. Also, or in Canada, but also yields to maturity on bonds and coupon rates are R1/2. So you need to divide them by 2 first to operate with them. That's document 2.2. Bye, Spencer. See you Tuesday. I will send you the notes for Tuesday. So whenever we mention bonds or mortgages in Canada, it's R1/2. So you have to take R1/2, divide it by 2, and work with this. For mortgages, you have to make a next step, and you actually have to find the monthly effective rate. But for bonds, all you have to do, you can just work with this number because bonds pay semi-annual coupons. Any other questions? So for people who need... Bye. Thank you, Komalpreet. So anyone who needs help with the mathematics, well, we're going to find out. Or I'm going to find out when I grade or see the graded papers. But if you're struggling with the mathematics, let me know. I'll see if I can help with that. Or maybe I'll have the TA have an extra session with people who are having problems with mathematics. I don't know if it's possible now before the test, but we'll find out. But you'll have to single yourself out and let me know, okay? If you're having problems with finance, then also let me know. Bye, everyone. Thank you for joining the class, the session, and communicating your questions to me. Bye. So email me if you have more questions. Text me. Did I put the number in there? I still didn't put the number. I got distracted. So text me if you need something. I'm forgetting my number now. 25879. I think. Have a good night. Have a good rest. Good night. You guys can even watch the videos while you're writing the test. That's fine with me. As long as you... It'll be best if you practice those so you know where everything is when you're solving problems. Bye, Hannah, Jason, Senna. Okay, you guys good? I'm gonna sign out. I have to do the timestamps for the videos. I owe you that, so I'll work on that tonight. Okay, good night.